In this tutorial, I will show you how to get from nothing to a manufacturable PCB in Kicad, a free and easy to use but still advanced EDA suite. More accurately, I will show you how to get from an idea to getting Gerber files of, in this case, 5V voltage converter. If you don't yet know what Gerber files are, don't worry, I'll get to that. This is a good example and you may be able to use this circuit in your future projects. I have used this voltage converter in another project already to power a server. This tutorial is done in the newest version of Kicad, the version 8, but both older and future versions as well as other programs should work too. To start, create a new project and give it a name. Then open the schematic editor. Now start by adding your components. Press A to open the component section and search for your part. In this case, search for the LM7805 voltage regulator. Then add two terminal blocks. Press A again and search for terminal. Select the 1x2 variant. You can rotate by pressing R. When you have placed it, copy it with Ctrl C and Ctrl V. Then add some capacitors. Some components such as resistors, capacitors and diodes can just be found by searching for the first letter, in this case C for capacitor. Add another capacitor on the other side of the converter. Now add wires by pressing W on your keyboard. Wires represent direct electrical connections between your components. It is not a problem when two wires cross each other in the schematic editor. Sadly, we are not done yet. Now we have to add footprints. Footprints define what the components look like on the finished board. So they define where the solder pads and through holes for the components go. Some symbols already have footprints with them, such as the voltage converter here, but you can still change the footprint if you want to use a different component. To add a footprint, double click on one of your symbols, such as this capacitor here. Then click on this symbol and search for capacitor 1206. The 1206 refers to the size of the capacitor. You can use other sizes too. I am using surface mount capacitors in the 1206 size as this is quite easy to solder. But you can use any footprints you want. Do the same thing for the other capacitor. And while you are at it, you can also change the value to what you want. In this case, for the second capacitor, 0.1 microfarads. The first one has a value of 0.2 microfarads. I got these values from the datasheet of the LM7805 voltage converter. For the terminal block, I would use the footprints of this Phoenix contact terminal block, but you can use any footprint you want. You might also want to directly connect your components if you use the voltage connector in your other circuits. Then select the same footprint for the other voltage converter. The next step is optional, but it's nice to have in a complex circuit. Add another symbol, this time ground, and connect it to the negative parts of your circuit, or ground as it's already here. Add another one, this time plus 5 volts. This goes to the output of the voltage converter as it outputs 5 volts, so to voltage out. And as the last thing, add plus 7.5 volts as this is my input from my batteries. Now you're done with the schematics. Nice. First hit Ctrl S to save, and then click on this button to switch to the PCB editor. First, I will explain the PCB editor a bit, because it seems quite cluttered at the start. On the right side you see layers. A PCB is a bit like a sandwich made out of layers stacked on top of each other. The most important layers at the start are the following: front and back copper, which are just a very thin copper foil that will make your conductive traces; front and back silk screen, which is for text and graphics; and the edge.cuts layer that define the outlines of your board. Just next to it are tools. At the moment important are just the select tool, the route tracks tool, and the VS tool. VS just connect the two copper layers. Up here is the grid setting. All of your components and tracks are on a grid, and this will let you change the size of the grid. I would use one of these sizes. On the left are some visual settings which are not very important. Now click on this button up here to import all of the footprints from the schematic into the editor. Then just click on Update PCB and put your components in the middle. Before you do anything else, start by changing the track widths. This just changes how thick the copper traces on your board are. You can calculate the needed thickness easily online, but a good rule of thumb is at about 1 amp, 0.4 millimeters should be good, and if you're way below it, the standard thickness should be okay. As the LM7805 can handle approximately 1 ampere, take 0.4 millimeters here. Then arrange your components. The layout can vary a lot, and you may have to try a few different layouts before you are happy. While with some boards, 2 layers, with that I mean sides of your PCB, are necessary because your tracks would cross otherwise, I would try to have as many things in one layer as possible. When you have found a nice layout, you can just connect all of the components. When arranging your components, try to not get the blue small lines tangled up, because they show you what has to be connected in the future. If you want, you can make your own layout, but if you want, you can also just copy mine at the end. Because I am happy now with the arrangement of my components, I can start routing now. Select your track width that you just defined and the front copper. Now the thin blue lines that are here show you which things should be connected. Press X to start routing. All of the things that should be connected will light up. If we want to route on the other side of the track, press V to change to the other opposite side. This will be indicated with another color. In this case we don't need 2 layers, so I'll just keep it to the front layer. I'm connecting the things very quickly and not very nicely, but I'll show at the end how it could look if you tried to make it look nice. Here, my connections don't look very nice, but they don't have to. You can just leave it as is if you're happy with it. You could also just make it look a lot nicer, but as I said, it's not really needed. Once there are no more blue lines, everything is connected nicely. Now you can look at your board under View and through 3D Viewer. The board outline is calculated automatically, but if you want, you can also define it yourself by adding a shape in the edge.cuts layer, as I said before. You can also put in a circle or something, if you would like to. If you want, you can also now add text on the silk screen layer. For that, just press T or click on the text tool. You also have to make sure you select the silk screen layer. Now you should be good to go. You can now press on File, Fabrication Outputs, Gerbers. Gerber files include all of the information about one layer. All of the settings in this window here should just be fine. Now you can just press on Plot. Most PCB manufacturers want you to place all the files that you have outputted into the directory you can specify up here, or the standard Kicad directory should be placed in a zip file. Most PCB manufacturers want you to place the files in a zip file. I hope you liked this tutorial. If yes, please like and subscribe. Bye! As a quick side note, here's what the board looks like if you put in a bit more effort. I also added some text. I hope you enjoyed this video. If yes, consider leaving a like. Otherwise, goodbye.